Okay. Before I move ahead, I'll take up a few questions. So one very good question that has come up. You found an error in this diagram. These arrows are drawn with solid lines, right? All the arrows which are self transitions have been drawn with a not a solid line, sorry, solid arrows, right? So I will make this correction and then only upload the slides. These arrows also have to be open arrows, right? So thank you for correcting me on this. I'll make this correction and then upload the slide. Next, uh, do we need to use pencil for drawing the diagrams? No, please do not use pencils for drawing the diagrams. We discussed this in one of the previous session as well. Please draw the diagrams with pen. So it is very important that you should be clear with what you have to draw beforehand, and for that please do some rough work. Use the uh, end pages of your answer script for doing the rough work. Once you are pretty sure about what has to be drawn, then draw it in fair using a pen. Please do not use pencil to draw the diagrams. Although I can understand it is easy to draw with pencil, right? But it is very important that you draw them with a pen so that you can apply for rechecks, right? So some diagrams drawn with pencil uh, would be difficult to be applied for recheck because it could be the condition that you've drawn with the pencil, then you've erased it, and then you've drawn on top of it. So things like that, okay? So please draw with a pen. Any type of pen can be used. I don't understand what type of pen you mean to say. So if you want to differentiate using different color pens, right? So you either draw the state with a black pen and then write the labels with a blue pen, something like that you can do. Yes, plus, but please do not go to the level of using sketch pens. Okay? Uh, Pen with scale of freehand line. So if you can use a scale, that would be a better idea to draw the diagrams, right? And even if you can find stencils somewhere, I don't know if they exist, such kind of stencils exist. So if you can find stencils for drawing these boxes for states or for activity diagrams, or you can make your own stencils and carry them, it's up to you. Okay, so there's a question. Can you please tell me what is open arrow and a solid arrow? Right, so different diagrams have different notations of the arrows. In state transition diagrams, the transitions are represented using an open arrow. Right, so this is an open arrow here, and if you see here, it's a solid arrow, right, which is incorrect in this particular case. It should be an open arrow like this. So in state transition diagram, your transitions are drawn with open arrows, right? Okay, I think no more questions. Let's move ahead with the class diagram, right? So that's the last diagram that we have in this particular course. The class diagram. Let's see what the class diagram has to offer to us. A class diagram is a static diagram, right? And it is used to depict the system structure in a static way, right? The other diagram for, say, activity diagram or state diagram, these are all behavioral diagrams. They depict the behavior of the system. Whereas your class diagram or your domain model, these diagrams are static diagrams. They depict the static structure of the system, right? The class diagram is also called as the design class diagram or DCD, and it depicts the software classes, right? So before I move ahead, uh, a quick distinction between domain concepts and class diagrams, right? So initially when we started, when we discussed about how to draw the domain concept, we said that in the domain concepts, we capture the conceptual objects, right? Only the real world objects. And then the domain concept, the domain diagram, right? So your domain diagram eventually evolves into a class diagram, right? And in the class diagram, what you depict is the software concepts or the software classes, right? So this is how a domain model differs from a class diagram, right? And if you remember the domain model that we had drawn earlier for a couple of case studies, or maybe for the snakes and ladders case study, uh, we drew the relationship between the various domain concepts, and every relationship had a direction of read. So there was a small black arrow that we had put in front of the relationship to depict the reading direction, plus the end of the relationship line or the association line had a multiplicity written at both the ends, right? This was the notation that we followed for the domain concept. Additionally, in the domain model, for every domain concept, we wrote the name for the domain concept and only the attributes of the domain concepts, right? The real world attributes that you can straight away visualize from the given case study were captured in the domain model, right? So is not the case in the class diagram. Now what happens in the class diagrams? Class diagram is the most common diagram which I think most of you would have drawn, and are also you also feel very confident about this diagram because you have drawn it so many times, right? So in a class diagram, what we capture is the software concepts, right? And derive your class diagram from the domain model, right? And in the class diagram, you depict not only the real world attributes, but your software attributes that your system, that your particular class will have, and along with the various operations that this particular class uh, has, right? So this is what you capture in a class diagram, okay? Okay, so let's see the notations of the class diagrams. Uh, there is a request to increase the volume. My volume from my side is at the right, so please adjust the volume at your end. Okay, let's see the notations. A class diagram, you use a rectangular box in order to depict a class or an interface. This rectangular box needs to be partitioned into three sections. The first section, you have the class name. The second section is the attribute section. And the third section is the section for operations or methods, right? So this is how you draw the class. All of you know this, so I'll just move ahead. More important things to come. Now let's see how you represent attributes in a class diagram, right? There are three ways to represent attributes, or which are also called structural properties of a class, right? The first way is to use the attribute text notation, right? Let me just check in the next slide, what do I have? Okay, so this is the attribute text notation, right? So I'll just go back. There are three ways to represent the attributes. One is the attribute text notation. The other is the association line notation. And the third is using a combination of the two, right? We will soon see what these two notations mean. right? Let's move ahead and understand what is the format of the attribute text notation, right? This is the format that you use to write an attribute within a class. Okay. First is the visibility of the attribute that you need to mention. Then is the name of the attribute, followed by semicolons, colons, and then the data type of the attribute, right? Then comes the multiplicity of the attribute, right? So I will discuss what we mean by multiplicity. And if in case the attribute is initialized to some default value, then you will put an equal to, write a default value there, followed by a property string, right? Now each of these words in the attribute notation signifies some aspect and describes something about the attribute. So we will see each one of them as we move ahead, but in totality, this is the format that is used to write the attribute text notation, right? Let's see first what do we mean by visibility, right? So visibility in UML, we have 4 visibilities that you need to represent or that you can represent, right? Your variable or the attribute can be public, private, package, or protected, right? And these are the 4 symbols that are used to represent the associated visibility. So if it's plus, it shows that it's a public, then it's a private, then this symbol is a package, and then hash symbol is protected. And by default, it is assumed to be private. So if nothing is specified, then by default, the attribute is referred to as having a private visibility, right? We will not go into deep into visibility before mid-semester. This one topic we will take in detail in the next, not the semester, in the next session, which is which will be a part of the post mid-semester portion, right? So as of now, for the class diagram, you can just pick up these 4 notations and use these 4 notations to represent the visibility of the attributes. Okay, let's move ahead. Now, if you have to represent the attributes using the attribute text notation, this is the way you represent the attributes, right? Now, what is important to notice here is that this register class has 2 attributes. One is an ID, which is of type int, right? So it's a normal data type. And there is another attribute that this register class has, which is called current sale, and it is of type sale, wherein sale is another existing class in the system, right? So my current sale attribute in the register class has an is of type sale, which is another class in my system, right? So this is one way of representing attribute, which is called attribute text notation. The other way of representing the attributes is this notation, okay, wherein I am putting an association line signifying that register class has an attribute of sales class which is named as current sale, okay, and its multiplicity is 1. So my register class has one attribute of current sale and it is named one attribute of sale, right, and it is named current sale. Right, so I'll just read through the slide. My attribute as an association line has the following style: a navigability arrow pointing from the source to the target. Right, so my register class is the source and it has an object of the target class sale, which is called current sale within itself. Right, a multiplicity at the end of the target but not at the source end. So there is a multiplicity which is written at the end of the target to signify the number of current sales attributes that I have within my register object or register class, right? A role name at the target end to show the attribute name, right? And there is no association name. There is no name that I give to this association line. It is only that you write the attribute name here and the multiplicity here, and there is a arrow which is used to depict this attribute association. Okay? Either you represent the relationship between register and sale, which is an attribute as an association line relationship using this method, or you represent it like this, which tells you that there is an object of sale class in my register class which is named as current sale. Right? I'll just take up a few questions that are coming. Multiplicity means one-to-one, many of a kind relationship. Yes, multiplicity stands for that. What would a multiplicity of 5 means? That there are exactly 5 objects of that kind. Where is the visibility in the register class? The visibility is mentioned for the attributes and the operations. If nothing is mentioned, by default, these are private variables or attributes. Okay, we will not use we should not use the word variables at this point of time. We call them attributes and operations, right? So if the visibility is not mentioned, it is by default private. Okay, I think that's it. I should move ahead. What is the use of the third box? The third box is used to represent the operations that are there in this particular class, right? So I have not, for this particular example, not just written down the operations just because it's an example in which we are trying to depict the attribute text notations. How to write multiplicity in the attribute text notation. So I go back, come forward to this slide. So here it represents that there is exactly one instance of the sale object in the register class, right? I will take up the next slide where you will understand, where you will have another example of multiplicity and you will be able to understand in much better way. Okay, there's a question, do we need to remember all the 3 notations? You have to use only one notation in your class diagram, right? Either stick to this notation in which you represent elements, attributes as association to line, or you use the previous notation, right? Okay, I'll take up the next one. So let's take this example. In this, if you see, my register class has one object of sale which is named as current sale and it has a multiplicity of 1, right? Again, it also has an attribute association with another class store, right? Wherein again the multiplicity is 1, right? Now if I convert this particular class diagram and try to depict it using code, this is what it would be, right? So my register class has a private attribute which is ID, it has a private attribute which is current sale, which is of type sale, which is an object of type sale, and there is another last private attribute that it has, which is location, which is of type store. Right? Let me take a few more questions about this. How are we representing the visibility here? I have not written the visibility here anywhere. If the visibility is not mentioned, it is by default private. Please, the visibility is mentioned for the methods and the attributes. Okay, one good question. Maybe I do not have the answer right now, or maybe it does not matter. The question says, is it not necessary to draw the arrow from the attribute section of the rectangle? Right, so what this person is trying to say that this particular arrow that I have drawn from here, which is originating from the operations section, should originate from the attribute section and be drawn like this. Okay, I did not think about that. Let me find out if it's to be drawn that way. But as far as what I understand, there is no restriction like that. Okay, so it would be drawn from anywhere from the complete box that is being referred by the class. However, I would still find this out and add it to the slides before putting this in. Okay, so this was a good question. Let me take up the other question. It says there can be n objects during the runtime. There are some questions about multiplicity. I do not understand what is the issue with the multiplicity. The register object has only one, the register class has only one object of the sales class, so you specify one on top of it, right? And that's the reason the multiplicity is 1. Okay, I'll take up the other slide. I think it'll be more clear. There's one more example here. Okay, let's move ahead. So this is another example. How do you represent collection attributes? Okay, so if you have an attribute which is a collection, say for example, it's an array of objects of another class, right? So how do we represent it using the class diagram? So this is the way we represent it. So the first way you can represent it is like this, right? You say that you have a line item which is a sale, which is of type sale line item. So this my sale line item is another class, right? And then you represent its multiplicity here, right? So when I say it is 1 to star, right? So this can be an array. If you know star, if you want to replace star with n, then you may say it is 1 to n. It can be 0 to n. It can be exactly 3. It can be exactly 4. So depending upon your condition, depending upon your case, you specify the multiplicity here, right? Moreover, this is another example of the property string. So if this line item collection is an ordered collection, then you can even use the property string ordered to specify here that this would be an ordered string, an ordered collection, right? So this is either this way or this way you can represent the attributes. The alternate notation, so this was based on the attribute text notation, the attribute association line notation. If you represent it using the attribute association line notation, then this would be the way you represent it. So the line items is the name of the object, which is of type sales line item, and there is an association between sales and sales line items. The multiplicity is 1 to star, right? And it's an ordered and it's a list, right? So you use the uh, keyword list to specify it's a collection, and you use the keyword ordered to specify that it's an ordered list, right? At times it might not be an ordered list, so you can omit the word order and only specify that it's a list, right? I'll take up a few more questions. If we write exactly 3, will it be in square brackets? If you're writing here or you're writing here, you can always use square brackets to specify the multiplicity. If you write 3, it means exactly 3 instances of that particular object. What do you mean by ordered? It's an ordered collection, right? So it's a sorted array or it's an ordered collection. So that is what ordered signifies. I didn't get the question. How to represent person address? Okay. How do we represent inheritance in class diagram? I'm coming to that. Okay. Okay. Let's move ahead. There are a lot of more notations that I want to add into this. And we're short of time. Okay, so let's take up more notations. The next notation is for representing operations, right? So how do we represent operations, or alternatively also called the methods, right? So this is the format of representing the operations. First, you specify the visibility, then the name of the operation, followed by the parameter list in brackets, colon, and then the return type of the particular method, right? If it's void, you do not specify anything. If there is no return type, don't specify anything. Otherwise, you mention the return type, followed by a property string, right? So this property string can be used to provide additional information, which could be the name of the exceptions that this operation might throw, or you can even use the keyword abstract to specify that this is an abstract method, right? So this is the format that we use to represent operations in a class diagram. The operations are assumed to be public if no visibility is shown, right? So this is important. In case of attributes, if no visibility was shown, then they were assumed to be private, right? And in case of operations, if no visibility is shown, then they are assumed to be public, right? The property string is specified using, the property string is used to represent the type of exceptions, and could be used to specify whether it's an abstract operation or not, right? One additional thing that UML provides is that you can use the signatures that you write for operations in the UML diagram could as well follow syntax of a particular programming language, right? I repeat, the signatures that of the methods that you would use to write in the UML diagram, in the class diagram, can as well be the signatures as per any particular programming language, provided you and the person who's going to write the code understands the same programming language, right? So this liberty is given when you write the or when you describe the methods in the class diagram, that you can use the syntax of a particular programming language to write the operations in the class diagram, assuming that both the designer, the analyst, and the person who would be actually doing the coding understands the same programming language. Okay, fine. I think this was it for the notations for the operations. Let's move ahead and see how the association between various classes are represented using the in the class diagram. Okay. The associations are represented using solid lines which are without arrows. Okay. The association name, which is also called a role name, is written on the top of the solid line, which is called the association line, plus the multiplicity of the association is written at both the ends of the association line, right? Okay. Now, this particular notation that is very frequently used in class diagram is derived from the domain model. Okay, I repeat, this particular notation of association lines drawn as solid lines with a role name written on top of it and multiplicity at both the ends is derived from the domain model. However, if you pick up the notations that I'm going to discuss now, okay, and depict only those associations in a class diagram, right, you would find that there is no need for these association lines. Okay, I repeat, these association lines which are used to depict relationships among the various classes are drawn from the domain model, right? However, your class diagram provides additional notations for depicting the relationships between the various classes, right? It is not wrong to draw these kind of association lines in class diagrams. However, I would also encourage and would also like to have the other kind of relationships drawn in the class diagrams. Now let's see what are the other kind of relationships that I'm talking about. Okay. The other kind of relationships are the dependency relationship between the various classes, right? How do we represent the dependency relationships between the various classes? The dependency relationships are represented using a dashed arrow, right? It's a dashed arrow as shown above, as shown in this slide. And on the top of this dashed arrow, you represent the kind of relationship or the kind of dependency relationship it is, right? It could be, okay, now I'll come to the kind of dependency relationship that could be there. So there could be a call relationship, there could be a use dependency relationship, there could be a send dependency relationship, there could be create dependency relationship, there could be instantiate dependency relationship, right? And there are many more. Once you start modeling these dependency relationships in your class diagram, right, you would find that the association lines that you have drawn in the class diagram can be actually removed, right? And your diagram transits from a domain model to the class diagram. Okay, I may be sounding very abstract, right? But let me try and be more clear. So given a domain model, you have to transform this domain model into a class diagram. The first step is to convert every conceptual element that you have into a software class, right? Then for that software class, identify the attributes that will be there. Identify the operations that will be there in the software class. Okay? Do not remove the association lines and the multiplicity. Leave the association lines and the multiplicity as it is. Okay? Once you have captured all the attributes and all the operations for each software class, now start drawing the dependency relationships, right? Once you have all your dependency relationships in place, you yourself will find that there is no longer a need for the existing association lines. And then you can remove those association lines, and then your domain model gets transformed into a class diagram. Okay, I have one example which is for the snakes and ladders case study. I will take up that after 2 or 3 more slides, and then I think it will be more clear what I want to explain. Okay, let's move ahead. So this is one example of a dependency relationship. Okay, I'll just take you through 2-3 examples of dependency relationship plus a few more notations. My class sale, okay, has an operation update price for, which has a parameter of type product description, right? And my product description is another class. Okay, my class sale has an operation update price for, which has a parameter which is of type product description. So my sales has a dependency relationship with the product description class. And what is that dependency relationship? Is that it makes use of the object of the type product description, right? So this is one kind of dependency relationship which can be modeled in a class diagram. Okay, let's move ahead. What is the other kind of dependency relationship that can be modeled? The other kind of dependency relationship is the implementation relationship, or which we also called as realization relationship. This kind of relationship exists between a class and an interface, right? So I might have an interface, right? And there would be another class which implements this particular interface. So this is another kind of a dependency relationship that a class has with an interface. Okay, let's just quickly notice the notations that should be there. So in order to represent that this particular classifier is an interface, we use the keyword interface to represent that this is an interface, and this is the notation that is used to represent the implementation relationship, right? It's a dashed arrow with an open with a unfilled solid arrow. Okay, I repeat, it's a dashed arrow. Okay, it's a dashed line with an solid unfilled arrow. You can see this arrow is different from the arrows that we have used in the previous notations, right? This kind of an arrow is used to depict an implementation relationship or an realization relationship wherein a class implements an interface. Okay. Let's see the other notation. This is for inheritance. Okay, so in the inheritance, where a class inherits from another class, so this is the kind of notation we use. This is a solid line, right, with an unfilled solid arrow. Okay, these two notations are very important. In fact, every notation is very important. So this depicts an inheritance relationship. Right? To represent an inheritance relationship, use a solid line with a solid unfilled arrow. How do we go about the abstract classes? So this is how we represent abstract classes, right? Either use the abstract word after the class name, right? Or write the name of the class in italics. Fine. So obviously, when you will be attempting the paper, you will not be able to italize something. So the best idea is after the name of the class, write the word abstract. Right? So when you, after the name of the class, write the word abstract, and it means that this is an abstract class. Right? So an abstract class. So in this particular example, you can see that this is an abstract class payment, right? And it is being inherited by three different classes: cash payment, credit payment, and check payment. Okay? Let's see the other notations. Okay, these are the last two notations, aggregations and compositions, right? What is an aggregation? It is an association that represents a part-whole relationship, okay? It is shown using a hollow diamond. So this is a hollow diamond. I think you can see here. On the end of the path attached to the aggregated class. Okay, so this is the aggregation. The UML package is the aggregation or the collection, and UML elements are the parts, right? So your diamond is placed at the side of the aggregation. So whichever is the aggregation, on that end is the hollow diamond placed. Okay, I'll give you an example. First, let's understand the composition. Right, now this is the composition relationship wherein the hollow diamond changes to a filled diamond. Okay, and it is placed at the end of the composite end. Right, now let's understand what is the difference between an aggregation and a composition. Okay. In aggregation, I'll go back to the previous slide. In aggregation, the parts can have individual existence. Okay? In aggregation, the parts, right? So my UML elements can have individual existence. Whereas, so is not the case in a composition. Okay? I'll give you another example of an aggregation. A bouquet is an example of an aggregation, right? A bouquet made up of flowers is an example of an aggregation. So all your flowers joined together, tied together, form a bouquet, right? But if I open up that bouquet, then each individual flower has its existence, right? So the relationship is not very strong in this particular aggregation kind of a relationship, right? If I open up the bouquet, every flower still exists, right? But so is not the case in a composite relationship. In the composite relationship, the parts get destroyed. If my composite or the whole is destroyed, that means my parts do not have an individual existence. right? Say for example, this one, as shown in the slide, a hand is a composition of fingers, right? The fingers do not have an existence if they are not attached to a hand, right? My fingers do not exist unless and until they are attached to a hand. So this is an example of a composition. Okay, I'll just take up a few questions. It says, what is 0 to 7 multiplicity? Oh my god, 7 fingers. Sorry for that. Okay, so it should be, I could say 5 to 6, not exactly 5 also. So some people do have 6 fingers. Okay, I think no more questions on this. Everybody is tired, so am I. Okay, let's see if there are more notations that I have to add. Okay, no more notations. So that's it for the notations. Now I will take last 10 minutes. Okay, I will just let me just share my screen, and then I will open the domain model that we had drawn for the uh, snakes and ladders, and then I will show you a partial class diagram for that. Okay, just give me a minute. Right, so I have the domain model with me. Where am I? Okay, I will just share my desktop. Okay, I hope you're able to see this. I will again open the chat. Right. Okay. Right, so this was the domain model that we had drawn for the snakes and ladders case study, right? I have drawn the partial class diagram for this model, okay, concentrating only on the snakes and the board part, okay. Just have a look at this domain model so that we can compare between this domain model and the class diagram that I have drawn, right? This was the domain model wherein we said that there is a snake, there are ladders, right? And the attributes that we thought of at that time, that there would be a starting point and ending point that every snake would have, and every ladder would have a starting and an ending point, and plus there is a board which has a matrix of cells, and there are association lines wherein it says that snakes are placed on board, ladders are placed on board. Okay, I will just stop sharing, and let me just go back to this, and we are here. Okay, right? So the first thing from transiting from a domain model to the class diagram is that capture the attributes and the operations, right? So I've tried to do that. This is only a very small portion of the class diagram. It's a partial one. The snake class has two attributes, start point and end point, right? And each one is of type int. Then it has two operations, get starting point and get ending point, right? And both of these operations return an integer, right? So this is the return type that I have specified here. Okay, a similar kind of attributes and operations exist for the ladder as well, right? Now my board is there. Fine. My board has a matrix, 10 cross 10 matrix for the array of the board, and I've got three methods here, okay, which is the configure board, which is public, and as is an is valid snake private method I have, right? So, and then a is valid ladder, right? These two methods are there which return Boolean, right? And these two methods are used when you configure the board, right? So when you configure the board, the the input is provided for the starting point and the ending point of a snake, right? And if you remember, we need to make a check whether given the starting and ending point, whether it would be a valid snake or not, right? So these two methods help you to find out whether it's a valid snake or not. Okay. Now I've captured one attribute association for this. My board, right, as was told in the case study, my game has, say for example, if I restrict it to 10 snakes and 10 ladders, or 8 snakes and 8 ladders, right? So I have, my board will have an array or a list of 10 snake objects or 8 snakes objects. Sorry, in this case I have put it as 8, right? So this is what my attribute, this is where I have depicted my attribute text association, attribute using association line, right? Wherein I'm trying to say that an attribute named as snakes on board, which is a list, right, exists in the board class. This attribute is of type snake, right, and it has a multiplicity of 1 to 8. So there could be 1 to 8 snakes, right? If the study says there can be only 8 snakes, then I will put a exact number 8 here, right? Okay. Then similarly, my board class has an attribute which is a list of ladder objects, right? My board is responsible for maintaining the list of snake objects as well as list of ladder objects. Instead of mentioning this list of snakes objects inside the board class as an attribute, I've mentioned it and drawn it as an attribute association line, right? Similarly, ladders on board using a list. Okay. Apart from that, you can also see here that I have another dependency relationship which is called instantiate, right? This dependency relationship signifies that board instantiates objects of class snake, right? Similarly here, board instantiates objects of class ladder, right? Here you can see it says game controller creates the board class, right? So these are the kind of dependency relationships that you must capture transiting from a domain model to a class model, and eventually the requirements of the association lines will vanish and all your association lines will get transformed into dependency relationships, right? Please go through the various dependency relationships and try to model and transform the domain model of the snakes and ladders case study into a complete class diagram. I will also add as a resource on the portal, I will add complete this class diagram and put it on the portal as well for this particular case study for you to understand. Okay, I think that's it for now. You are also tired and I think my voice is also totally gone. I'll just take up a few questions. Why not solid lines between game controller and board, right? The solid line has been transformed into the dependency relationship, which is an additional notation that exists between which is an additional notation that exists in class diagrams. When multiplicity is written in range, multiplicity is written in range whenever there is the need for a range, right? So whenever there is a collection, a list, you write the multiplicity in range. Is class diagram considered for mid-semester? Yes. Uh, Board class does not have any attributes for snakes and ladders. It is not shown. The attributes are written using the different notation, right? So there can be two notations for writing the attributes. Either you capture it here in the class or you capture it using an association line. So in this case, I've captured it using an association line. Okay, a few more questions. You want me to explain the composition and aggregation again? Okay. Another question, can we go for solid lines of representing association, the solid line notation? Yes, you can use the solid line notation to represent the association in a class diagram as well, but you should have you should capture some of the important dependency relationships, right? So make a mix of it. You can put the association lines as it is, but do try to capture some of the dependency relationship so that the examiner understands that you understand the additional notations that are there in a class diagram. Okay. What about dice, roll and coin, etc.? I've mentioned that this is a partial class diagram. I have not drawn those classes here, right? I would appreciate if you would complete this class diagram. Okay, take 2 days time, complete the class diagram. Don't always wait for me to upload the diagram, right? Please do it at your end, and within 2 days I will also upload the class diagram, but take it as an understanding for yourself. Do it at your end and then cross check with mine. Okay. If we create an attribute of type board and replace the dotted line with the solid line, will it be wrong? No. Again and again you're asking the same question about the chapters to be referred from the textbook for the mid-semester examination. Please, I've already posted an announcement about the mid-semester exam syllabus, and it is of in three parts. Okay, I've specified the video lectures that you should go through. I have specified the live lectures that you should go through, and I have specified the chapters also which you must go through. Okay, so please refer to the portal announcement for the same. In this case, snakes and ladder number is fixed, so why we are writing the multiplicity? When I drew this diagram, I had the idea that it is not fixed. The number of snakes and ladders could range anywhere between 1 and 8. So if that is the case, you specify the multiplicity between 1 and 8, right? But if it's fixed, then you will write it as 8. Too many diagrams for the mid-semester. Could you give us a question bank or way to remember them easily? No, I cannot. Please use the slides. Please go through the um, live lectures, go through the videos, and go about it. Okay, I think enough for today. If there are any more questions, please post them on the portal. I will answer to them. And please go through the group list and check if your name is not there. Please do write a mail to me. Okay, I will look into it. Thank you so much for today. We'll meet next time. Tomorrow there is no session, right? This is important. Tomorrow, Sunday, we do not have a session. Thank you.